So we've learned there's 5 types of reactions, but today we want to dive deeper with the type called a single replacement reaction.
These are my favorite, I gotta tell you.
Your favorite. Now, as a note, what's the general form of the single replacement reaction? It's
A plus BX.
Makes
now
AX.
Before you do that,
okay.
Yeah, before you do that, let's just walk through what actually is happening here.
Okay.
Think of it like a dance. So B is dancing with X, right? And A walks along, and A's all like, and this, by the way, is a bad sign if you're B. A doesn't even look at B and looks at X and is all like, how you doing? And the X is all like, ho. And all of a sudden the A takes the place of the X and becomes AX. And here's the horribleness of this. The B doesn't get to leave. It ends up having to still stay at the dance. He's over there by the punch bowl, just thinking to himself, looking over longingly, like, I remember how happy I used to be. So
Mr. Demetrius, what if I did this? What if B shows up at the dance and A is dancing with the girl? What happens?
Yeah, so let's just pretend, just for sake of argument, let's pretend that A is football McHandsome and B is scrawny clarinet. Now, this is not a slight on clarinets. It's just my sister played it all her life and I hated it. So if B comes up to A and is all like, get out of here. What do you think is going to happen there, Mr. Bergmann?
He's going to punch him and it's all over and he's just going to keep the girl. Yeah, so the answer here, folks, is this. No reaction. Nothing will happen because A, for whatever reason, is the more attractive dude and B just loses every time.
So we can't just arbitrarily look at something and go, well, I think that will work and that won't. We have a table that kind of helps us out with this. Kind of like a table of
attractability or something. I don't know.
Or King of the Jungle, however you would. Let's take a look at that real quick.
Yeah, so you can see the table here, and who's at the top of the table? Who's like the most attractive dude on the planet?
So lithium is literally the best of all time.
Yeah, lithium is really hot.
Yeah, every girl's like, oh, and every guy's like, I want to be him.
Yeah, and then who's at the bottom of the table?
Ironically enough, we have gold.
Yeah.
Gold is at the bottom. Gold cannot get any I was going to say action, but I don't think that that's a good expression to use.
Actually, it makes sense if you think about it, folks, for a moment, that gold actually likes to be by itself, and that's one reason why it's the valuable metal that it is. Lithium doesn't like to be by himself. He has to always be with somebody else. There's probably some psychological thing.
Yeah, I don't know that we can. Thing.
Yeah, we're going on there, but. The question when you're doing these problems is you're going to get reactions, and sometimes the answer is going to be no reaction, because when you do these reactions, you have to consult the table. You can steal the table, it's in your chart there, and you got to figure out what will happen. So let's just do a 3 examples, Mr. Dimitrievich, and then see if we can predict the product. So
why don't we just go calcium plus aluminum nitrate.
Now, folks, I am really quickly in my head building the charges of these things right here. So calcium plus aluminum nitrate. And now I have to look at the table. Take a look at the table. Who's on top? Who's the attractive guy? Is it calcium or aluminum?
Yeah, so you just look at it. Whatever one's higher up on the table wins, right? So in this case, you can see if you put your finger on calcium, calcium's higher up than aluminum. So calcium can kick aluminum to the curb.
So it's going to make CaNO3 2. Now you say, wait a second, 2s and 3s, why is that? Because calcium is charged, as it says in the table, and our periodic table is +2, nitrate's -1. It does this, and it then kicks out the aluminum. Aluminum loses the game, and we can trade the arrow game. And again, I'm going to go fast here. The problem is I got 2 nitrates and 3 nitrates. This will be a 2, this will be a 3, and a 2. What's another example, Mr. Dimitrievich?
Before that, let me just jump in here real quick. It is really important. What Mr. Bergmann is doing is anytime you put two out, like you swap something out, you're writing a new compound, you must balance the charges. So he did it really quickly, but you're always balancing off the pluses and minuses like we've done before. Let's try another example here. Let's go with sodium plus potassium chloride.
That K is +1, chloride is -1. And then first question, does it even happen? Who's more attractive, Na or K?
And this is where we're going to take a look here. If you take a look where Na is and where sodium and where potassium is, Na is actually lower down than potassium. So what does that mean, Mr. Bergmann?
K gets the girl.
Yeah, K keeps the girl. There is no reaction in this case.
But it turns out sodium is actually a pretty attractive guy, but K is just a little bit better, right?
Yeah, it's just a matter of a couple spots up on the table.
Yeah. And so, folks, on these problems, essentially what you're going to do is you're going to consult the table, get one of two answers, do the full ball game, get the reaction, or sometimes you just say, oh, didn't happen, no reaction. Are there any other weird examples that you want to talk about?
Well, if you take a look at the bottom of the table, we have halogens, and I'm going to just give one example of this. So if you take a look at the bottom of the table, you have halogens, and this is really important. It's like a separate table completely. So if you ever see a halogen, there's only 4 of them we have to worry about: fluorine, bromine, iodine, and chlorine. If you ever see one of those by themselves at the beginning, so let's say, for example, we have chlorine. So if you see Cl2 by itself, and it's trying to react with something like potassium bromide.
Again, that's +1, -1. That's why it's KBr. I played the game in my head very fast. Now the question is who's it more attractive? Is the chlorine or the bromine? Because in this case, it's like who's the good-looking girl, right? If the non-metal is considered the girl and the metal is the boy. So potassium's the only guy in town. So who gets the girl based on the chart?
Well, chlorine happens to be 1 step higher than bromine, so chlorine gets to replace bromine.
So it becomes K. Now charge game. I'm going to put it over again. K is +1, Cl is -1. I don't use Cl2, I use the charge, and that becomes KCl plus Br2. And that's because Br is one of the Brinkelhoffs. To balance that, you simply need a 2 right there.
Yeah, so in this case here, remember, if you ever have a halogen by itself, it always is a diatomic with a 2. When you put it into a compound, it immediately dresses itself up with a charge to be able to hook up.
Yep. So, folks, that's how you do single placement reactions. You're gonna be working on these and lots of problems and do a cool lab. So, yeah, we'll see you in class.
See you next time.